It really feels like one day we were all just going about our business, and then bam! The next day, generative AI was just everywhere. Suddenly, it's writing our emails, it's creating these unbelievable images, it's changing pretty much everything. This is not just a buzzword anymore, folks. It is a full-blown revolution. So let's dive in and figure out exactly how we got here. Right, that's the big question, isn't it? It feels like it just appeared out of nowhere, this overnight sensation. But as we're about to see this overnight success story, well, it was actually decades in the making. So what was the tipping point? What really kicked off this explosion? Okay, check this out. This slide shows you the exact moment the world changed. This is a chart of Google's search interest, and for years, it's basically a flat line, nothing. And then, right at the end of 2022, when ChatGPT came out, whoosh, it's a vertical rocket launch. That was the moment this tech went from a science project in a lab to something in all of our living rooms. But look, ChatGPT was really just the spark that lit the fuse. The explosion itself? That was caused by a perfect storm of things that had been brewing for years. First, you have this insane explosion of data to train these things on. Then, we finally got the raw computing power to actually handle all that data. On top of that, we had some genius algorithmic breakthroughs, which we're going to get to. And maybe most importantly, companies made it incredibly easy for anyone, and I mean anyone, to get their hands on this tech. All those ingredients just came together at the exact right moment. So, to really understand what's happening now, we have to zoom out. Way out. This isn't just a story about the last couple of years. Nope. This is a story that really starts more than 60 years ago. So let's trace the long, winding path that led us to today. First things first, let's just get our bearings. This slide is perfect because it shows you exactly where generative AI fits in the grand scheme of things. Think of it like those Russian nesting dolls. The biggest doll is artificial intelligence. Inside that, you have machine learning. Then inside that, you have deep learning. And right at the very core, the smallest doll, that's generative AI. It's the most specialized part of this whole field. And here are the super quick and simple definitions. AI, that's the big dream, right? Making machines smart. Machine learning is one way to do that, basically by having them learn from data instead of being explicitly programmed. Deep learning takes that a step further, using these complex structures called neural networks. And then generative AI, well, that's the creative part. That's the part that actually makes new stuff, whether it's text or code or images. Okay, now take a look at this timeline. For decades, progress was, steady, but pretty slow. We had early chatbots, new kinds of networks. But do you see that date? 2017, the transformer architecture. That right there is the inflection point. That single invention changed the entire game and made everything that followed, from GPT-3 to ChatGPT to all the crazy models we have today, it made all of it possible. So that 2017 transformer was the revolutionary software idea, the new blueprint. But a blueprint is useless without an engine powerful enough to actually build the thing. And that brings us to the second key ingredient in this whole explosion, the hardware. And here is that engine, the GPU, the graphics processing unit. Yeah, you've probably heard of these things from the world of video games, right? Well, it turns out that their very special design is absolutely perfect for the kind of heavy-duty math that powers modern AI. This slide just illustrates the difference perfectly. On the left, you've got a CPU, the brain of a normal computer. It's built with a few really powerful cores, designed to tackle complex jobs one after another. But on the right, you see the GPU. It takes a totally different approach. It's not a few powerful cores, it's a whole army of thousands of simpler cores, all working at the same time in parallel. And here's really the best way to think about it. A CPU, that's like a brilliant generalist, maybe a CEO. They can do a few really complex things, but one at a time. A GPU, on the other hand, is a specialist army. It can't do those super complex tasks, but it can do thousands and thousands of simple, repetitive math problems all at the exact same moment. And guess what? Training an AI is basically just trillions of those simple, repetitive problems. So let's be crystal clear about this. The crucial point is this. Without the parallel computing power of GPUs, the AI revolution we're living through right now simply would not be happening. Full stop. It would be too slow, way too expensive. It would be totally impractical to even try. They are the essential engine. So once the world figured out that GPUs were the secret ingredient, what do you think happened next? Yep, a classic gold rush. But this time, the gold wasn't some shiny metal in the ground. It was compute power. and a frantic global race began to get as many of these chips as humanly possible. You know that old saying, right? In a gold rush, the people who get truly rich are the ones selling the shovels? Well, in this AI gold rush, the undisputed #1 shovel seller is NVIDIA, the company that just so happens to make the most powerful GPUs on the planet. And the scale of this gold rush it's just hard to even wrap your head around. I mean, look at this, the Stargate project, a plan to invest $500 billion in new AI infrastructure. And who's the key partner helping to build it? You guessed it, NVIDIA. And it's not just some future mega project. Every major player is scrambling for these things right now. Here's Elon Musk just casually announcing that his team brought a cluster of 100,000 of NVIDIA's top-of-the-line H100 GPUs online. 100,000. And that's just one company. And even that isn't enough. It's never enough. Here's OpenAI's CEO, Sam Altman, saying they'll cross 1 million GPUs this year, and then says this team's next job is to figure out how to get 100 times that amount. The demand is absolutely, positively insatiable. So what does this all mean in terms of, money? Well, this number says it all. In the last 5 years, right as this AI gold rush has been taking off, NVIDIA's stock has grown by over 1,500%. That right there is the power of selling the shovels. This slide shows how all that demand for hardware creates an entire ecosystem, what people in tech call a stack. So follow it from the bottom up. The absolute foundation, the bedrock, is the compute hardware, those GPUs we've been talking about. Then, built on top of that, you have the cloud platforms that rent out all that power. Then come the big AI models themselves. And finally, at the very top, you have the apps that we all use, like ChatGPT. The key thing to see here is that everything, the whole pyramid, rests on that one foundational hardware layer. Okay, so the tech landscape is set. The gold rush is in full swing. And that has led to this massive, almost philosophical battle that's brewing over how this incredibly powerful technology should be developed and shared with the world. And the big question is this: should AI be open or should it be closed? Here's the basic breakdown. With an open source model, the core code, the secret sauce, is made public. Anyone can download it, they can tweak it, they can run it on their own machines. That gives you a ton of flexibility. Proprietary models, on the other hand, are total black boxes. You can use them through a company's service, but the model itself is a closely guarded secret. It's usually easier to get started with, but you have way less control and transparency. And this is not just some abstract academic debate. You can see the battle lines being drawn right here with all the companies you've heard of. You've got the giants like OpenAI, Anthropic, and Google, who are mostly in that proprietary, closed camp. But then you've got other heavyweights like Meta and Mistral who are really championing the open source approach. It's a fascinating split, right down the middle of the entire industry. And so that's where we are right now. The engine of this whole revolution, the GPU, is built and it is running red hot. The fuel for that engine, the data and the algorithms, is getting better and more refined every single day. The only real question left, and it's the biggest one of all, is in this huge battle between open and closed AI, who is ultimately going to end up in the driver's seat, steering the future for all of us?